So our second way of factoring is called difference of squares. So difference means you have to do what? Subtract, and the squares is talking about our perfect squares. So like 1 squared is a perfect square, 2 squared is a perfect square. We're going to make a list all the way up to 225. Whoa, it's really not going to take that long. What is 3 squared? 4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64. 9 squared? 81. Sorry.
You're okay. What about 10 squared?
100.
11 squared?
124.
Good. What about 12 squared?
144.
What's 13 squared?
Calculator. 169.
14 squared?
196.
What do you think 15 squared is going to be?
225.
Oh, I have all that on the side. You can see. Is that all right? So those are all our perfect squares up to 225. So 1 through 15. You're probably never going to have to go that far. They usually stop around 144. Okay. So you probably don't have to memorize higher than that. So that's your list of perfect squares. So again, we got to make sure that it's difference. So subtracting. And they got to be squares. So your first term is a perfect square and your second term is a perfect square. So then when we factor that out, you're going to have a plus b, a minus b. So basically we're just taking like what is going to give you a squared. Or what's like the square root of a squared. So what times what would give you a squared? A times A. What times what would give you B squared? B times B. That's where that's coming from. So that's how these are all going to factor, okay? So if we're looking at the next one right here, what do you always check for first when you're factoring anything ever? Is there anything that these two have in common that we could divide out? Nope. So there's no GCF. We're going to try difference of squares now. So difference, again, means they have to be doing what? Subtracting, which they are, so that's good. And then is x squared a perfect square? Yes. Is 9 a perfect square? Yes, that was on our list, so these are good to go. We can do difference of squares here. So you'll set up your parentheses. What times what would give you x squared? X times x. And what times what gives you 9? 3 times 3. We need 1 to be plus and 1 to be minus. Do we know why one has to be positive and one has to be negative? Because a positive times a negative is a negative here. And then how could we check our answer? Multiply that with the box. Exactly. So when we do that, you don't have to write this down if you don't want to, but I just want to show you how all this is coming together. We're going to do x plus 3, x minus 3. What is x times x? And then x times negative 3. X times positive 3. Positive 3 times negative 3. What happens? These guys cancel. So you're just left with that x squared minus 9. So you've got to have those, everything's the same except for your middle signs. That's what makes your middle term cancel, so that we just get that x squared minus 9. So that's where that comes from. For difference of squares, yep, every time. Is that okay?
Yeah.
Do we have any other questions right now?
No.
You ready to try another one?
Yeah.
So looking at the next part, anytime you're factoring anything ever, what do you always check for first? GCF. So between 4x squared and 25, is there any number we could divide both of those by? Will 25 divide by 4? Oh, that's about it then, right? Because 25 is not even, so we couldn't do 2. And 1's not going to change anything. So do they both have x's? Nope, so there's no GCF. So let's see if we can do difference of squares. So are they subtracting? That's that difference part.
Yeah.
Yes. Is 4 a perfect square?
Yeah.
Is x squared a perfect square?
Yeah.
Is 25 a perfect square?
Yeah.
Yes, so we can do difference of squares. So you'll set up your parentheses. What is the square root of 4?
2.
2, so that means that like 2 times 2 would give us 4. What's the square root of x squared? X, because x times x gives you x squared. What's the square root of 25?
5.
What has to be our signs in between? We need a plus, we need a minus. I'm going to highlight that up there. We have a line that says that one factor must have a plus and one must have a minus. That's super important here, so I would highlight it. But then again, how are you going to check your answer to be sure that this is factored correctly? You can do the box. Is that all right?
Yeah.
Yeah? All right, so at the bottom there, we've got a bunch to try. I don't want to do them all with you, but let's do a few. Let's pick some that y'all want to do. I definitely want to do number... Can we do 7 first? No. Yes.
Yeah.
Yes. We can do 7 and we can do 8. Pick another one. Or 2. 14? Anything else?
5.
9? Okay. Alright, so we're looking at number, these are all tricky. They're all bigger. Actually, can we go a little bit easier first? We're going to do 5 and 6 as well. We're just going to do a lot together, but that's okay. So looking at number 5. What do you always check for first? GCF. Do we have one between these guys? Probably not, right? Because 49 and 100, they're both not even, so you can't even divide by 2. So that's probably not going to have a GCF at all. Do they both have W's that we could pull out? No, so there's no GCF. So we're going to try difference of squares. Are they subtracting?
Yeah.
Yes. Is 100 a perfect square?
Yes.
Is W squared a perfect square?
Yes.
Is 49 a perfect square?
Yes.
Yeah. So we're good to go for difference of squares. So I'll set up a parentheses. And what's the square root of 100? Do we know where these numbers are coming from, y'all?
Yes.
Yeah, if you're not sure, we wrote out that list. So like 100 was 10 squared, so 10 and 10. Is that okay? What about W squared? What's going to give us that? Just W times W. What's the square root of 49? What do our signs have to be in between? A plus and a minus. Doesn't matter which one goes where as long as you got one of each. Is that okay? Questions? Alright, looking at number 6. We've got x squared plus 4. So anytime you're factoring anything ever, what do you always check for first? Do we have one? Nope, because they both can't be divided by 4. They both don't have x's, so there's no GCF there. Then we're going to check for difference of squares. Do y'all think we could do difference of squares there? What does the difference part mean? Subtracting. Are these subtracting? So we can't factor this. What's that word we use when you can't factor? Questions there? All right, now we'll go on something a little bit harder. So number 7, we've got 10 m to the 10th minus 16. What do you always check for first? Do we have a GCF here? Probably not. So let's try difference of squares. Are they subtracting? Difference. Do we have that? Yes. So then we've got to decide. I know that 16 is a perfect square, right? But what about m to the 10th? I don't know. What do y'all think? Okay, so how is something a perfect square? How does that work? So something times itself would get us there. So you're going to have m to the something times m to the something. I'm going to write that out. M to the something times m to the something is supposed to give us m to the 10th. Do you agree?
No.
What's our rule when you're multiplying terms with like bases? What do you do with the exponents? So what plus itself is going to give you 10? So is m to the 10th a perfect square?
Yes.
Yeah. Is that okay? Does that make sense?
Yeah.
So I want you to write off to the side. your exponents have to divide by 2. That's how it's going to work, okay? So as long as your exponent is divisible by 2, or like an even number, then it'll be a perfect square. So if we have y to the 4th, is that going to be a perfect square?
Yeah.
If we have w to the 6th, will that be a perfect square?
Yeah.
What if we have b to the 3rd?
No.
No, that wouldn't work out. Is that okay? So it's just got to be an even exponent. You got to divide them by 2. Got it right? Good? Questions? Okay. So we're going to do that with number 7. So we'll set up our parentheses because we know that this is going to factor like difference of squares. And what did we say is going to give us m to the 10th? M to the 5th times m to the 5th. So again, we just divided that exponent by 2. So 10 divided by 2 gave you 5. And what's the square root of 16? 4. So we'll have 4 in the back. And what are our signs in between? We need a plus, we need a minus. Is that all right? Questions? So number 8 is going to be basically the same thing. What do you always check for first when you're factoring anything ever? GCF. So between 16 and 25, is there something we could divide both of those by? What about variables? Do they have the same variable? Nope, so there's nothing we could do there as far as the GCF is concerned. So let's try difference of squares. Are they subtracting?
Yeah.
Is 16 a perfect square? What about y to the 4th? 25? W to the 6th? Everything's a perfect square, so this is going to work out beautifully for us. We'll set up our parentheses. And what's the square root of 16? So we'll have a 4 and a 4. What's going to be the square root of y to the 4th? Y to the 2nd. So again, you're just dividing that exponent by 2. What's the square root of 25? 5. And what's the square root of w to the 6th? Yeah. Divide by 2. So w to the 3rd. And what are our signs in between? We need a plus, we need a minus. Doesn't matter which one goes where. Questions on that? So we're okay? Alrighty. We said we wanted to do number 9. Do y'all still want to do number 9? Okay. So what do you always check for first? GCF. So do we have one between 49 and 81? I don't think so. And then there's no variables on the 81, so you can't plot a B or anything. Let's try difference of squares. So are they subtracting? Yeah. Is 49 a perfect square? Is B to the 12th going to be a perfect square? How do we know? It's even. You can divide by 2, exactly. And then is 81 a perfect square? Yes. So we'll set up our parentheses and go ahead and factor that. So what is the square root of 49? What's the square root of b to the 12th? How are we getting that? Divide your exponent by 2. I wrote 2 instead of 6. B to the 6th. And then what's the square root of 81? What are our signs in between? Plus and minus. So that's b to the 6th on both of those. I just wrote the wrong number the first time. Questions there? Alrighty. Instead of 14, can we do 12 instead?
Yeah.
Okay, let's do 12. So, if we're looking at number 12, we've got 20x to the 6th minus 80. Anytime you're factoring anything ever, what do you always check for first?
Yeah.
Do we have one?
Yes.
What can you divide 20 and 80 both by? Anything else? 20, right? So let's divide both by 20. That's going to be our GCF. So we'll have 20 on the outside, and then 20x to the 6th divided by 20 is just x to the 6th. Then what's 80 divided by 20? So we'll have minus 4 inside our parentheses. Now that we pulled out that GCF, we want to see if we can keep factoring, if we can go any further. So ignore the GCF out front. We're just looking at x to the 6th minus 4. Do you think we could do difference of squares there? Probably, right? Because it's subtracting. Is x to the 6th going to be a perfect square?
Yeah.
What about 4? Yeah. So we're going to factor that further. Leave the GCF out front. Nothing's happening with that. And then we'll set up our parentheses just like we have been. What's the square root of x to the 6th? X to the 3rd, x to the 3rd. What's the square root of 4? 2. What are our signs in between? Plus and minus. Questions on that? Anything we're not sure about, don't understand? Do we need to see another one worked out? Alright, so I want you to do the rest on your own. And we'll go over them in just a second.